Now we know how we can execute a plain PHP view and get a string from it, but that's still not quite Blade, is it? Blade has its own custom syntax that isn't 100% like normal PHP. So, how does Blade achieve that? Well, the first thing to know is that when you try to render a Blade file with something like the view function, it doesn't get executed directly. Instead, there's a compilation process it goes through first, which then outputs a plain PHP file, usually into your storage framework views directory. And this is the file that then gets executed to render your template. You'll notice the compiled view file looks a little different from the Blade template, but you'll still see some similarities with the code that you wrote. So if you think of PHP templating as a way to pre-process HTML, you can think of Blade templating as a way to pre-process PHP. So let's figure out how our code on the left turns into the code on the right. We're going to dig into the source code of Blade a bit, but there will be a lot of code we skip over while we focus on the important stuff to get an idea of the main structure of the code. We'll dive further into some of the other bits that we skip over in later episodes. We can begin by taking a look at where everything starts, what we call the view function. This is the function we're probably most familiar with calling when we try to use Blade, but if we call something like the root view method, or the inertia helper function if you're using inertia, or even trying to render a livewire component, it's going to be doing pretty much the same as this. We can see the function first resolves the view factory from the container, and then calls the make method on it. And it's important to note that the view function doesn't actually return a string like lots of people think it does. It actually returns an implementation of the view contract, which is usually the view class itself. This means we get an object back from it, and we can call additional methods on it before it's returned to the browser if we want. If we look at the view class, we can see one of those methods is render, which is where the actual compilation and evaluating process happens. And that's an important thing to remember. Having an instance of the view class doesn't mean the template has been compiled and evaluated yet. So we can call these additional methods on the class before that happens. Where does that method get called though? We just returned an instance of the view class in our root. Well, Laravel's actually smart enough to call that itself. In fact, in the HTTP response class, if we look at where it sets the content for the response, it does a check to see if the content that we passed it is an instance of renderable, which the view is, and then it calls the render method off of that to just get a string and pass that to the browser instead. But the view render method itself mostly defers its logic to the render contents method, which again, the main logic we care about is inside the get contents function. Each of these steps usually do some additional things too, but Laravel's entitles are actually pretty well commented, so if you're curious about what else it's doing at these stages and want to dive in, these comments will certainly help you to understand some of the things that aren't so obvious. But the getContents method then invokes the get method on the engine. The concept of engines is something we'll cover further in a later episode, but for now all you need to know is that a view can actually be rendered with multiple different types of engines, and Blade is just one of those engines. If we take a look at Laravel's view service provider, we can see that the Blade engine actually gets registered as an instance of the compiler engine class, but with a Blade compiler passed in as the first argument. But the compiler engine class still isn't quite Blade. It could be used to handle additional compilation steps, or even for other syntaxes or languages if we wanted it to. But if we have a look at the get method on the engine, which is what the view is calling when it's rendering, we can see one of the things it does is call the compile method on the compiler itself, and we know that this is the Blade compiler that gets passed in when it's resolved from the container. If we have a look at the Blade compiler class itself, and then the compile method, we can see it actually gets the .blade.php file's contents, and then runs it through the compile string method. So now we're really starting to look at Blade itself, and not just the many layers of abstractions that wrap around it. And as we can see, the compile string method will just compile the given Blade template contents. Before it does the real compilation that we care about, it first goes through a few additional steps. Firstly, it strips out any blocks of code that shouldn't be compiled by Blade, like anything in verbatim tags or PHP directives, which can then be put back in later after everything else has been compiled. It then strips out any Blade comments and replaces them with an empty string, so that they don't end up in the resulting compiled file. And then it precompiles the Blade component tags that were introduced in Laravel 7, and it goes through a few steps to do that, which we'll focus more on later. But anyway, after it set up these tags, the Blade compiler takes the source code through a set of precompilers. Like many other things you might have noticed with Laravel, this is another kind of hidden feature that isn't documented, but it can be really powerful. It's just a way to run a set of callbacks over the source code to modify it before it goes through the main compilation steps. We're going to take another look at that in more detail in a later episode to see how it can be useful and how we can register our own precompilers. But after it's run the precompilers, it takes the source code and runs it through this token getAll function. And this is just a way to make sure that if you have any raw PHP tags in your Blade file, they don't get passed and compiled by Blade. They'll just be appended to the compiled view without anything being done to them. But anything that isn't in a PHP tag will go through the passToken method. And this then checks if the given token is counted as HTML, which might sound confusing, but remember that normally .php files are really just plain HTML files until you open a PHP tag. Anything outside that will be treated as plain HTML by the token getAll function, even if it looks like we've got logic there in Blade. So in that scenario, we'll try and run that HTML code through several compilers. In order, that's going to invoke the compile extensions, compile statements, and compile echoes methods. The compile extensions function offers another undocumented way to extend Blade's functionality yourself, which again, we're going to skip over now and cover in a later episode. The next compiler down the list was the compile statements method. And this one is really what Blade is at its core. This is probably what comes to mind when we think about Blade. It finds any statements that start with an @ symbol, like @if, @foreach, or @component, and then it parses them and sends them through the singular compile statement method, which is where the magic actually happens. There's actually 3 different paths it can go down from here. The first one checks if the statement's name starts with another @ symbol. So for example, if our Blade file has a statement like @click, it won't do any further compiling on this, and it'll just put the string back together. This is a way that we can prevent Blade from compiling a directive by escaping it with another @ symbol, in case we need to use the string of @click somewhere else, like in an inline view template or an Alpine.js component. The second one it will check for is custom directives, and these are just the kind of directives we might register in our own service provider with the Blade directive method. When you call that method, the callback basically just gets stored on the compiler to be invoked at a later point in time. And finally, the built-in directives is part of Blade's core get compiled. But we should really pay close attention to the order of this. Custom directives get compiled before the core ones. This means that we can override a core Blade directive like @if in our service provider. If we wanted to, we could really mess with someone by doing something like making an if statement in Blade only pass half the time. But obviously you don't really do that to someone, it's not a practical thing to do. But this kind of thing is possible and it does have genuine uses. For example, if you've got an authentication system that isn't using Laravel's auth guards at all, you might want to override the auth directives in Blade to work in a way that makes sense for your own authentication system. But let's go back to those first-party Blade directives again. We can see it tries to call methods on the current Blade compiler class, where the method name starts with the word compile, followed by the directive's name. All of the core directives actually live in traits on the compiler class that encapsulate a set of concerns that they deal with. For example, if we look at the compile's conditionals trait, we can see some of the most basic examples like the if directive, to see what the blade directive really compiles down to in raw PHP. But we can also use this to start looking at some more complex directives to see what they do under the hood, like to see how the auth1 checks for authentication. But in a handful of internal blade directives, for example, if we go back and look at the compile include trait and the compile include directive on that, we can see this weirdly named $__env variable used several times. And this isn't a variable that we passed into the view ourselves, it's kind of implicitly set. It actually comes from the view factories constructor, where it sets the factory itself as a variable to be shared with this view. You'll see lots of directives use this variable internally to access state in the view, like being aware of what section or component it's currently rendering. We can see the include directive actually just calls the make method on the factory, which is exactly what the view function itself did to render the view in the first place. Now, that's just a couple of directives, and obviously there's so much more we could go over. Blade has nearly 100 different directives itself. But up to this point, we've only covered the compilation process to turn Blade syntax into PHP syntax. If we go back to the compiler engine, we'll see the next step is actually evaluating the compiled contents. If we look at the actual evaluation process, you should notice it's doing some pretty familiar things. Just like our plain old PHP function did before, this starts an output buffer, and cleans it up after itself, and in the meantime it requires that file. But before it requires the file, it extracts the variables into scope. And there we have it. From there it returns a string which we can push out to the browser to have it render as the HTML that we want. And that's basically how Blade's compilation process works in a nutshell. There's obviously more to it than that. Like I said, Blade has lots of different directives and a number of other features. But now we've gone over the fundamentals, you should have a better idea of how to explore the codebase yourself and where to look for different things. We're going to continue in the next episode by taking a look at some of the specifics we glossed over here.